resistor, it's got a capacitor, yay, and it's got another resistor. And I'm connecting this to a 10-volt battery. That's 2 ohms, that's 5 ohms, that's 2 henries for the inductor, and let's say 3 farads for the capacitor. I'm now going to close that switch when time equals 0 seconds. Before I close that switch, what's the voltage across the capacitor?
0.
0, correct. Before I close the switch, what's the voltage across the 5 ohm resistor?
0.
0. Before I close the switch, what's the voltage across the 2 ohm resistor?
0.
Yep. Before I close the switch, what's the voltage across this inductor? Ryan.
0.
Before I close the switch, what's the current through the inductor? Vaughn.
0.
Before I close the switch, what's the current through that 2 ohm resistor? That's 0. 0. Okay. There's your final exam, right? That would be easy.
Yes.
No switch ever gets closed. We just ask about everything. But I do ask on exams and stuff. I do mix in some easy questions that, in hindsight, you always go back and say, "Oh, you know." So be on the lookout for that. Before I close the switch, what's the current through the inductor? 0. After I close the switch, what 2 things about the circuit cannot change instantly?
The voltage and
Which voltage, which current?
the voltage going to the 3 farad capacitor can't change instantly.
Okay, so that voltage can't change instantly. There's one thing. Someone else. What other thing in the circuit can't change instantly?
The current in an inductor.
Correct. So just after I close the switch, the current through the inductor is what, Fred?
Just after you close the switch?
Yep.
Oh, it would have to be
Well, the current through an inductor can't change instantly. So just after I close the switch,
it would be 0.
0. What's the voltage across the capacitor just after I close the switch? Isaac?
0.
0. Yep. Okay, so we've got 2 things figured out already. Can we figure out everything else? If that voltage is 0, no, excuse me, if that current is 0, so just after I close the switch, that current is 0. That voltage is 0. So just after I close the switch, how much voltage is across that 2 ohm resistor?
10.
10.
It'd be 5 amps.
The full 10, because the voltage across that capacitor is 0. If I go around this loop, starting here,
And this is right after you close.
right after I close the switch. Right after I close the switch, that voltage is 0. So that voltage has to be 10. Right after I close the switch, the voltage across that 2 ohm resistor is 10. So how much current is flowing through that 2 ohm resistor?
5 amps.
5 amps. So that's 5 amps just after I close the switch. What's the current right here just after I close the switch, Sean?
5 amps.
5 amps, good. What's the current through the inductor just after I close the switch, Roger?
0.
Correct. What's the voltage across the capacitor just after I close the switch, Ryan?
0.
What's the voltage across that 5 ohm resistor just after I close the switch, Benson? If these 2 are in parallel, that voltage is 0. Then that other one's got to be 0 also. You can go around this little loop right here. If that voltage is 0, that voltage has to be 0. If I go around this loop starting here, up, and then down back to there, those voltages have to add up to 0.
But if you
So if that's 0, then that has to be 0.
go around the other loop from the inductor to the resistor,
Like that?
no, from the 10 volts to the inductor
Like
to
that?
the resistor, yeah. Doesn't that then have to be 10 volts?
And that has to all add up to 10. So up 10, if I conclude that 0, then what's the voltage across the inductor?
10.
It's
Oh,
got to be 10.
so the inductor can have voltage.
The voltage across the inductor can
Change instantly.
Okay.
Because of the equation.
Yep. Yep. But good question, Isaac. Isaac said, well, inductor, does that mean the voltage is 0? Do we have a problem? We're okay. So if that voltage is 0, that voltage is 0. What's the current labeled right here just after I close the switch? Where to leave off? Matt. The voltage across that 5 ohm resistor is 0. What's the current through it?
5.
No. Well, the voltage across that 5 ohm resistor is 0. So then that current's going to be 0. That current right there, we already decided was 0. This current is 0. What's that current labeled right there, Karen?
5 amps.
What?
5 amps.
Well, this current right here is 0. That current right there is 0. This current is going into that node. So if you look at this junction right here, there's some amount of current going in. There's 0 and 0 in the other two wires. So that current going in has to be how much?
0.
0, correct. So that current right there is 0. That current right there is 5 amps. What's the current then flowing onto the capacitor?
5 amps.
5 amps. Okay? So we've kind of figured out everything in the circuit. The currents through and the voltages across every component just after I close the switch. Now, after a second goes by, or a tenth of a second, things are going to start changing. And we have to use that differential equation approach to actually get the exact equation. It's going to have e's in it, e to the negative something t, and we do some work. But after a long amount of time, we can come back and just figure out what everything is without having to go through all that. Let me clean up my picture here just for a moment. So I'm going to put the same picture down. Okay, this was 3 farads, 2 henries, 2 ohms, and 5 ohms. Now I'm interested in what everything's going to be after a very long amount of time. After a very long amount of time,